We're going to look at inverse functions today. And an inverse function is a function that reverses another function. So what does that mean exactly? As I was practicing by doing the homework over this topic, I had to really plan out how I wanted to show everything to you. So first of all, let's go back a little bit and recognizing that the function of x equals 2x plus 2. And let's start there. So the first thing that I'm going to do is I'm going to make a table, and I'm going to use one of my three-legged tables that I like to do. And here's my x, here is 2x plus 2, and here's my y. So I'm going to plug in negative 1, 2 times negative 1 plus 2, so negative 2 plus 2 is 0. 0, I have 2 times 0 plus 2, so 0 plus 2 is 2. 1, 2 times 1 plus 2, 2 plus 2 is 4. And then lastly, I'm going to do 2, so 2 times 2 plus 2, so 4 plus 2 is 6. All right, so if I wanted to graph this, and I'm going to be first quadrant heavy, so I'm going to kind of do more this direction. Got a little too much fourth quadrant. Negative 1, 0, and I'm going to, I think, plot in a different color so we can see it. So we have negative 1, 0. We have 0, 2. We have 1, 4, 1, 2, 3, 4. And we have 2, 1, 2, 3, 4, 5, 6. So here is my function, and I'm going to label him f of x so I don't lose track of him. And if I was going to find out the domain, I would be saying that I went from negative infinity to positive infinity, and the range is also going to be from negative infinity to positive infinity. All right, this is a first degree function. It's a line. This is not a situation if I was dealing with, for instance, time and money or distance. I can only stay positive. Okay, which means I'd have some restrictions placed on that. But this is a line, and therefore I can go from negative infinity to positive infinity. Now, how do we make the inverse function? So super simple is we reverse it. But how do we do that? So what I'm going to do is I'm going to write to find the inverse right here. Let's do that so we don't lose track of what we're up to. And I don't want to forget how to do this when I am at home, so I'm also going to bubble it. So when I'm looking at my homework or looking back over at my notes, I'm okay. I was given y equals 2x plus 2, and I'm going to remind myself that this is the original function. What I want to now do is I want to switch the x and the y. I want to reverse it like we talked about up here. So I'm going to write x equals 2y plus 2, which seems really strange. And I'm going to circle this y because I need him back by himself again. So logically, I'm going to move that 2 over. I have x minus 2 equals 2y. To get the y again by himself, I'm going to divide by 2. And remember, I'm going to put a little dotted line under here so y'all remember this is a next step. I have y equals 2, x minus 2 over 2. Now, I can't confuse this y for this y. So what I'm going to do is I'm going to write this as f to the negative 1 x minus 2 over 2. And this is the inverse. This means inverse. All right, so this reminds me what I'm doing. Now, the next thing I want to do, and I've got kind of a little tight on room here, but we're going to go back up to this original graph in a second, is I'm going to again make a table right here. And I have x minus 2 over 2 equals my f prime of x. Now, remember up here I just had y, which I could have called f of x. You'll see me go in and out. And down here I'm going to remind myself that I'm on the inverse. So I'm going to start with the same numbers again. Negative 1. And I have negative 1 minus 2 over 2. So I have negative 3 divided by 2. And I'm going to do a little simple stuff here. I have negative 1.5. 0. 0 minus 2 over 2 equals negative 1. 1. So I'm going to have 1 minus 2 over 2, which is negative 1 over 2, so negative 1/2. 2. So 2 minus 2 over 2, so equals 0. And I'm going to actually kind of skip ahead a little bit. I'm going to pick 4 this time. 4 minus 2 over 2. So 2 divided by 2 is 1. And I'm going to go 6. And 6 minus 2 over 2 is 4 divided by 2, which is 2. Now, what I want to look at, and you may be wondering, well, why did you start skipping all of a sudden? I want you to pause the video a second, and I want you to look between this chart and our chart up here, and do you notice anything? And then come back and start the video again. All right, so hopefully you've paused and looked. And this is what I'm noticing, and I'm going to have to zoom out, so hopefully y'all can see okay. Negative 1, 0 matches up to 0, negative 1, but it was reversed. 0, 2 is a reverse of my original. 1, 4. Reverse it. 4, 1. 2, 6. Reverse it. 6, 2. Now, do we have to make tables every time? Absolutely not. We do not have to do that. But sometimes it is easier to understand what's happening so you can discover it. So now what I'm going to do is I'm going to use my red pen that I've been noting everything as the inverse in, and I'm going to graph these new points. I'm going to stay away from those negative, the half ones, just because it's a little weird and harder to see. So zooming back in for you, I have 0, negative 1, 2, 0, 1, 2, 3, 4, 1, and then 6 and 2. And I have something that starts looking like this. And this is going to be in my f prime of x. Remember, label your functions on your paper so you see what's going on. Now, hopefully you're also noticing this looks kind of familiar to what we did in geometry. And I know you hate me saying that word geometry, but do you notice that this is a reflection? This is a reflection over the line y equals x. Y equals x. Okay, so there's my reflection. I took the coordinates and I flipped them, and those give me my new sets of points. So little did you really know, when you're doing reflections, you're actually doing the inverse. So that's kind of cool. Now, let's talk a little bit about inverses more. Make sure we kind of understand some special things about them. Okay? Key things to note on inverses. First, the inverse, may not be a function. That's okay. Sometimes it's going to happen and may require a restriction, which you're going to learn about a little bit later. The other thing that's going to happen is we're going to have situations of one-to-one functions. Okay, so if we have one-to-one, one-to-one functions means that every x goes to a y and every y goes to an x, and they don't repeat on either side. Okay, so if you are a one-to-one function, then remember our geometry symbols. If this happens, then the inverse f negative 1 is also our function, which is kind of pretty cool, I think. All right, so that's the beginning of our inverses. Best of luck as you're going through them. We're going to have a short video on the composition of them just so that we keep our videos short, and we'll do a lot more practice in class. So have fun with your practice. Do not be afraid of them, and it will require a bunch of our algebra skills to keep coming back. Good luck.